Now let's start with the thermodynamic properties. You all are aware about thermodynamic properties that we have already done in first year also. That some intensive properties are there, some extensive properties are there, like temperature, pressure, volume. They come under this category of properties of a thermodynamic system. Now we are to bring it to related to that fluid mechanics, right? Now fluids consist of liquids or gases. There anything that can flow is of two types. Either it will be a liquid or a gas, but gases are compressible. Or you consider all the gases as compressible. We compress air also. We compress liquid hydrogen petroleum gas also. All gases are compressible fluid. Hence, thermodynamic properties plays an important role. As liquids have some different properties and gases are compressible, they are having some different properties. So thermodynamic properties plays a very important role in that. With a change of pressure and temperature, the gases undergo large variation in density. When you increase the pressure, when you increase the temperature, or decrease the pressure or decrease the temperature, the gases undergo large variation in density. The density varies with the temperature and pressure. The relation between pressure, absolute pressure, when you're talking about pressure, absolute pressure, specific volume, and temperature of a gas is given by the equations as P is absolute pressure, inverted A, which is specific volume. Inverted A is specific volume, that is equal to RT. R is a gas constant and T is temperature. Now that can be written as inverted A can be written as density, specific volume as 1 over density. So P pressure over density is equal to R into T. This is the relation that is being used to calculate different properties for this fluid mechanics related problem, right? P into inverted A, that is specific volume. You read this as specific volume. R is gas constant and T is temperature, particular gas constant, right? Just write this equation. You may be asked some numerical afterwards. You can write this numerical. Sorry, this equation that can be asked or used for solving some numericals also. P inverted A is equal to RT. PV is equal to RT hota hai, and PV P by rho is equal to RT. Just write this equation and that can be helpful in solving some numericals also. Thermodynamic property is the value of gas constant R as 287. You can take this 287 fixed for in this particular fluid mechanics case, 287 joule per kg Kelvin. Isothermal process, I think you all are aware what is an isothermal process. When if the changes in density occurs at constant pressure, then process is called an isothermal process. For this particular case, a fluid mechanics, when temperature remains constant and pressure and volume changes, we call it an isothermal process, right? But for fluid mechanics purposes, if the change in density occurs at constant temperature, when temperature remains constant, the process is called an isothermal process. You can take that also. If you are asked to write what is an isothermal process, you can write that also, that if temperature is kept constant and pressure and volume varies, then it is called an isothermal process, right? So the relation between pressure and density will be written as P by rho is equal to constant. Similarly, for adiabatic process, in other words, isothermal is written as P V is equal to constant. PV is equal to constant in case of isothermal process. But for fluid mechanics purposes, P by rho is equal to constant. Now, adiabatic process, if the change in density occurs with no heat exchanges, same process that we have studied in first year also, then there is no exchange of heat between the system and the surrounding, then that particular system, that particular process is called an adiabatic process. If the change in density occurs with no heat exchange to and from the gas, the process is called adiabatic process. And if no heat is generated within the gas due to friction, the relationship between the pressure and density is given by. Now, the relation that is governing the adiabatic processes P, that is absolute pressure or pressure divided by density raised to power K is equal to constant. We are not taking volume over here, we are taking density, right? Now, thermodynamic properties, where K is ratio of specific heat of gas at constant pressure and constant volume. You may have seen this P by rho raised to power K. What is K? In adiabatic process, the governing equation is PV raised to power gamma equal to C, right? This K is equal to gamma. Now, gamma is further equal to Cp by Cv. The ratio of Cp by Cv is called gamma. Now, what is Cp? Cp is specific heat at constant pressure, and what is Cv? Specific heat at constant volume. Anybody who knows what is specific heat, you can give a definition. Now, next term is compressibility and bulk modulus. Now, compressibility is the reciprocal of the bulk modulus of elasticity K, which is defined as the ratio of compressive stress to the volumetric strain. Compressibility, what is compressibility? How much you can compress a particular gas, that is compressibility, and that is equal to the reciprocal of the bulk modulus of elasticity, which is defined as the ratio of compressive stress to the volumetric strain. Compressive stress to the volumetric strain that you have already studied in strength of material. Now let us consider a cylinder fitted with a piston as shown in the figure. Now V is equal to volume of gas enclosed in the cylinder. P is the pressure of gas when volume is V. Now let the pressure increases from P to delta P. The volume of gas decreases from P to delta P. When pressure will increase, the volume will automatically decrease. Now see this diagram that I am talking about. When this piston pushes when this connecting rod pushes this piston to right side, now the pressure inside increases, and on other hand, the volume is decreasing, right? This is all we are talking about. Now V is the volume of gas enclosed in the cylinder. This is the cylinder, and V is the initial volume, and P is the pressure of a gas when volume is V. Now let the pressure is increased from P to delta P. When pressure is increased, now when you push this piston towards left side, now pressure is increased inside this cylinder. When pressure is increasing, that volume is decreasing. And the volume of gas will decrease from V to delta V minus delta V, right? Then the increase in pressure is dP, change in pressure is dP, and decrease in volume is dV. Now volumetric strain, that you all know, volumetric strain is dV by V, total volume, a change in volume over total volume. Negative signs mean the volume is decreasing with the increase of pressure. The bulk modulus K is increase of pressure over volumetric strain. dP is the change in pressure over minus dV by V, and that is dP by dV into V. So this is the formula to calculate bulk modulus, and compressibility is 1 by bulk modulus. Compressibility is given by 1 by K. That is shown in your diagram. This slide, compressibility is given by 1 by K. K is bulk modulus. Bulk modulus is increase of pressure, that is increasing when the piston is pushing this air to left side. This volume is decreasing, that is decreasing by dV volume. Small volume change will be there. Total volume divided by total volume minus dV by dV. Now this negative sign is because that the volume is decreasing. That's why we have taken a negative sign over here, right? Now next topic is surface tension and capillarity. Now surface tension, let me explain this. Then we will read this out. See this diagram. This is a particular molecule inside the liquid, and this molecule lying on the surface of this liquid. Uh, as I have discussed, we have discussed about cohesive force and adhesive force. The forces that are existing between similar molecules, that is called cohesive forces. And when you talk about forces that exist between different molecules, right? The surface of this container, this container, and this liquid, if they attract each other, that is called adhesive forces. And the molecules, those are similar, right? Water molecules are attracting each other. That particular force is called cohesive forces. So this concept basically is of cohesive forces. This surface tension exists because of cohesive forces. Just listen to me very carefully. What is cohesive forces? First of all, you must know what is cohesive and adhesive forces. Adhesive forces are those forces that exist between liquid molecule and the container, say steel container or glass container. These two molecules attract each other, glass molecules and water molecules. These forces are called adhesive forces. And similar forces, similar molecules like H2 and H2O. If you talk about this is the water. They attract each other. Then that particular attraction is called cohesive. So, what is on surface tension? This is all about because of cohesive forces. One molecule is lying inside the liquid, and one molecule is lying on the surface of the liquid. One molecule that is inside, that is observing equal forces from all sides. यहाँ पे भी molecule है, यहाँ पे भी molecule है, यहाँ पे भी molecule है, यहाँ पे भी. So it is being attracted from all sides in with equal forces, right? So it is neutral inside. Now the molecule that is lying on the surface of the liquid, they are net force observing a force net downwards. It is attracted by the same molecules inside, same molecule this side. No molecule is above that. So net, they are observing a net force towards downwards. So the surface of the liquid will remain in tension because the net force that is acting on that molecule that is lying on the surface is being towards the center of that particular liquid, right? I hope you have understood this. Now let us read this once again and then I will explain this again. Now surface tension is defined as the tensile force acting on the surface of a liquid in contact with a gas or on the surface between two miscible liquids such that the contact surface behaves like a membrane under tension. You may have thought that taking a cup of tea and some other liquids, when you're containing that, the surface of that particular liquid is under tension. That particular tension is called surface tension. Now, surface tension is created due to the unbalanced cohesive forces acting on the liquid molecules at the fluid surface. Unbalanced cohesive forces, uh, forces that are, uh, as I have discussed also, that there can be two types of molecules that are lying inside and on the surface of the liquid. So this unbalance, that the molecule that is very inside that liquid will observe equal forces in all directions, equal forces of attraction from all sides. It will observe equal forces, then it is neutralized inside the liquid. The molecule that is lying on the surface of the liquid will observe a net downward force. As the net downward force is acting on that particular molecule, the membrane will behave like a stretched membrane, and that is attracted towards the center of that particular liquid. Now, molecules in the interior of fluid mass are surrounded by molecules that are attracted to each other equally. However, molecules along the surface are subjected to a net force towards the interior. The apparent physical consequence of this unbalanced force along the surface is create the hypothetical skin or membrane. No, this is not a skin or membrane, but behaves like a membrane. So this is the diagram. Let me explain you once again. What is surface tension? We must know what is cohesive forces and adhesive forces. I have explained this one or two times that cohesive forces are the forces that exist between molecule of similar nature, like H2 and H2O attract each other. That particular forces is called cohesive forces. And we are talking about adhesive forces, a dissimilar metal or dissimilar liquids, or when they are in contact with each other, they attract each other, and that force is called adhesive force. So the phenomena of this surface tension exists because of this cohesive forces. Now, cohesive forces, how does it exist? There is a molecule, let's say H2O water molecule, that is lying inside the liquid that will absorb equal forces from all sides. It is attracted from all sides with equal force, and hence it is neutral at its position. And some molecule that is lying on the surface, it will be absorbing a force net downward. There is no molecule at the top that is going to attract this. So hence, there is a net downward force acting on this molecule. And because of this downward force, that membrane or the top surface of the molecule will be acting like a membrane that is attracted towards the center of that particular liquid. Now, tensile force may be considered to be acting on the plane of the surface along any line in the surface. The intensity of the molecular attraction per unit length along any line in the surface is called surface tension. Now, the definition for surface tension: the intensity of molecular attraction per unit length along any line in the surface is called surface tension. You want to define something, surface tension, you can define it: the intensity of molecular attraction per unit length along any line in the surface is called surface tension. Now it is denoted by a Greek letter sigma. It is read as sigma. That is on your screen, sigma. Now SI unit in is Newton per meter. So moving ahead, now let us first take one bowl